Good day, guys. This is your maths facilitator, Sir Steve, and you are once again welcome to my YouTube channel, Maths Tutorials. Our new topic is on integration. We've learned something on differentiation. So, integration or integral calculus is a continuation of differentiation. The process of integration reverses the process of differentiation. So, when we integrate, or when we find the integral of a function, is the reversal or the reverse of differentiation. For example, in differentiation, if we have y is equal to 2x squared and we are to find dy over dx, or to differentiate y with respect to what x, we are going to have 4x. So when we differentiate 2x squared, we get what? 4x. But in today's topic, when we integrate or we find the integral of 4x, we are going to get 2x squared. So which shows that the process of integration reverses the process of what? Differentiation. So the integral of 4x dx will give us 4s squared over 2. I will show you how we had this. So this will cancel that, then we will get 2s squared. So when we integrate 4x, we will get 2s squared. So we can see that when we differentiated 2s squared, we had 4x. But when we find the integral of this, we had our question back. So this shows that the process of integration reverses the process of what? Differentiation. Okay, in integration, we use an elongated x to replace the word integral of. So in integration, we use this elongated x. This is x. So we just elongate the x to show that we are integrating. So we use this sign to replace the integral of. So anytime you see this elongated s, it means what? You are finding the integral of. Good. So when I write, let's say 2t dt, we are talking about the integral of what? 2t with respect to what? T. And this will give us 2t squared over 2. This will cancel that, leaving me with what? T squared, leaving me with t squared. I'm going to show you how we had all this, how we had this t exponent what? 2. So this is just an intro to integration, or what we call integral calculus. So in integration, we'll be using this sign, the elongated s. Good. Now let's look at the general solution of integrals of the form ax raised to the power n. The general solution of integrals of the form ax to the power n. we are saying this rule is true when n is fractional, n is 0, or a positive or negative integer, except n is equal to -1. Okay, so we are looking at how to find the general solution of integrals of the form ax exponent n. So we have our integral sign of ax exponent n what dx. We are integrating with respect to what x. So this is the general formula. So anytime you are finding the integral of, you add 1 to the power, then you divide it by the whole power. So anytime you are integrating, you add 1 to the what? To the power. Then you divide by the whole what? Power. So you can see that here was ax to the power n. So we will add 1 to the power divided by whatever power that we have, which is what? N plus 1. Now I hope you can see some c here. Yeah. The c is called the constant of integration. So anytime you're integrating without the limits, we talk about that. So anytime you're integrating without any limits, we add what we call the constant of what? Integration. So anytime you're integrating without any limits, after finding the integral of, you add plus c to it. But assuming you were given the limit, which is the lower limit and the upper limit, you would have gotten a specific what? Value. In that case, there will be no sense for us to add the constant of what? Integration. But for indefinite integrals, we add the plus c to it. And the c is the constant of integration. So this is the general solution of integrals of this form, ax to the power what? N. Just add 1 to the power divided by the whole what? Power. And if it's an indefinite integral, you add plus c to it. This rule is only true when n. So this rule is only feasible when the n is a fractional, a 0, or positive or negative what? Integer. With the exception of -1. With the exception of -1. Negative integer. With the exception of -1. So when the power here is -1, we can't apply this rule. That's the meaning. And we have a way of dealing with such questions. Such questions are for higher learning, and we will come to that one too. So for now, let's concentrate on this. So this rule is only true for fractional when n is fractional, 0, positive or negative what? Integer, with the exception of what? -1. So n here cannot be what? -1 at this level. At this what? Level. At certain level, when you have it to be -1, we have a way of what? Dealing with it. We introduce what we call the length. For example, when I have the integral of 1 over x, something like this. So we come to such integrals, but for now let's concentrate on this. So having known the rule for find the integrals of this form, now let's take some examples to what we've just explained. So we first look at the indefinite integrals. Integrals without what? Limits. So we are going to find the integrals of the following. The first example is the integral of 3x exponent 4 dx. So we are first looking at the indefinite integrals. Integrals without what? Limits. We call them what? Indefinite what? Integrals. Now let's see how we can find the integrals of the following. And the first one is the integral of 3x exponent 4 what? Dx. Solution. In integrating it, how do we go by it? You will just add 1 to the power divided by the whole what? Power. That's the rule of what? Integration. As simple as that. So the first one, the integral of 3x to the power 4 dx is equal to 3x 4. Then I'll add 1 to the power divided by the whole power, which is what? 4 plus 1. And because I'm dealing with indefinite integrals, that is integrals without what? Lower and upper what? Limit, I will add plus c to it, where c is the constant of integration. So now I'll get 3x 4 plus 1 is what? 5 divided by 5 plus c. And that will be my final answer. So this is just simple. It's so simple as that. You can take our second example. So this is our second example. The integral of 2 over x squared dx. Solution. So the integral of 2 over x squared dx is equal to, before I can integrate this, I need to find the inverse of this first before I can integrate. Because we just said that in integrating of this form, we add 1 to the power divided by the whole power. And before I can do that, I need to find the inverse of this. So this one will give me the integral of 2x exponent negative 2. So when you take the inverse of this, you get negative 2 exponent negative 2 dx. So now that you can integrate. Now let's take note of something here. I'm still having the integral sign here because I haven't started to integrate. But when I'm about to integrate, you will not see the integral sign again. So let's take note of that. So you get 2x negative 2, and the rule of integration says add 1 to the power plus 1 divided by the whole power, which is negative 2 plus 1. And because I'm dealing with indefinite integrals without limits, I'll add plus c. And the c is my constant of integration, where c is my constant of integration. So I will have 2x, negative 2 plus 1 is negative 1 divided by negative 2 plus 1 is negative 1 plus c. 2 divided by negative 1 will give me negative 2. So I will have negative 2x exponent negative 1 plus c. Now we take the reciprocal of x exponent negative 1, which will give us negative 2 divided by x plus c. So this will be our final answer. This should be our final answer. I hope you are finding it so easy and interesting. Yeah. Please take these topics so seriously because in engineering, most of the calculations are centered around integration, especially double and triple what integration. So let's take this topic seriously. Let's move to our third example. I hope I can clean it. Good. Example 3. Okay, so we have the integral of what? Root of x d what? X. We have to integrate this solution. Before we can integrate this, we need to remove the square root sign from the what? X. And we will have what? X to the power half d what? X. So now that the square root has been removed, we can now what? Integrate. And I hope you remember the rule of integration of this form. Add 1 to the power half plus 1 divided by the whole power, which is what? Half plus 1 plus c. Do you remember the c? The c is a constant of what? Integration, since we are dealing with indefinite integrals without limits. Good. Now half plus 1 is what? 3 over 2. So we get x to the power 3 over 2 divided by half plus 1 is 3 over 2 plus c. We finish with the integration aspect. We are going to deal with some simple algebra. We are going to deal with some simple what? Algebra. Okay. Now we can write this one as x to the power 3 over 2 divided by 1. I'll change this division sign to what? Multiplication. This 2 become numerator divided by the 3 will become what? A denominator. Plus my c is c. Let's me decide. So you're going to have x is for negative 3 over 2 times what? 2, which will give us 2x to the power 3 over 2 all over 1 times 3 is what? 10 plus c. Now let's do simple algebra here. I'll have 2 over 3. X to the power 3 over 2 can be written as x to the power half times 3. Do you agree? Of course, you should agree with me. Now, x to the power half is the same as what? Square root. So we have 2 over 3 square root of what? X, because x exponent half will give me one square root to the power what? 3 plus c. And this should be our final answer. This should be our final answer. We are moving on to our fourth example. I hope I can clean a word. The fourth example. Okay, before we move on to this example, let's look at something here. When we integrate a constant, for example, I have the integral of 8 dx. 8 is a constant. Why is it a constant? Because it's not having any variable attached to it. So the 8 becomes what? A constant. So when we integrate any number without a variable, we call it what? A constant. And that one will give us 8. Then I'm integrating with respect to what? X. So I will have what? 8x. So in short, when we integrate, let's say 2 dx, you will get what? 2x. So anytime you are integrating a constant, just add the variable you are integrating with respect to that what number. So the integral of, let's say, 7 dx will give me what? 7x. Let's take note of that. Now, solution. This one will give us, I've just applied the rule to this. 4x to the power 3 plus 1. The rule of integration, I'll add 1 to the power. Divided by the whole power, which is 3 plus 1. Plus, I'll do likewise for this. 2 plus 1 divided by 2 plus 1. Minus 2. What is the power of this x? Is 1. In math, we don't write it. But when it comes to calculation, we should know that this x is having exponent of what? 1. So that 1 plus the rule of integration, which is 1, divided by the whole distance, which is 1 plus 1. Plus, I'm integrating what? 7. So it becomes what? 7x. Because this is a constant, it's not having any what variable, so it becomes what? 7x. So now I have 4x to the power 4 divided by 4 plus 5x to the power 3 divided by 3 minus 2x to the power 2 divided by 2 plus 7x. So now let's do some cancellation. This can take care of that. This will take care of that. Leaving me with what? X to the power 4 plus 5 over 3 x raised to the power 3 minus x squared plus 7x plus c. Don't forget the constant of integration. Plus what? C. And this will be my final answer. X to the power 4 plus 5 over 3 x cube minus x squared plus 7x plus c, which is the constant of what? Integration. Because we are dealing with indefinite integrals. Let's deal with our last example for the day, and that will be our 5th example. Okay, this is our 5th example. Integral of t squared minus 2t to the power 4 divided by t to the power 4 dt. So here we are finding the integral of t squared minus 2t to the power 4 divided by t exponent 4 dt. Solution. Before we can integrate this, we need to do simple algebra here. I'll have the integral of t to the power 2 divided by t to the power 4 minus 2t to the power 4 divided by t to the power 4. So we just divide each of them by what? T to the power 4 or dt. we're going to have, here I can apply what indices. Here I'll have t to the power 2 minus what 4. When the bases are the same, you subtract our other powers. Minus, you can take care of that, leaving with minus 2 d what t. So I'll have them right here. Integral of t to the power minus 2 minus, because 2 minus 4 is what? Minus 2. Or dt. So all this while you saw the integral sign, because I haven't started to what? Integrate. I was just doing some simple algebra there. Now that I'm finished with that, I can now go on to what? Integrate. So in this case, you will not see the integral sign again, because I'm going to integrate. It's equal to, the rule says add 1 to the power. So minus 2 plus 1 divided by minus 2 plus 1 minus, when we integrate 2 with respect to dt, you get what? 2t. Don't forget, plus my constant of integration. So I'll have t to the power negative 2 plus 1 is what? Negative 1 divided by negative 2 plus 1 is what? Negative 1 minus 2t plus c. Now t divided by negative 1 will give you what? Negative t exponent minus 1 minus 2t plus c. Now let's take the reciprocal of this. We get what? Negative 1 over what? T. When we take the reciprocal of t as for negative 1, we get what? 1 over what? T minus 2t plus c, and that will be our final answer. Where c is my constant of what? Integration. C is my constant of what? Integration. So far, we will take these 5 examples, and I entreat you guys to go over it, so that in our next meeting, you'll be abreast with it and we can move on faster. Please, guys, do subscribe and share the video to your other colleagues. Maybe some of your colleagues might be in need of integration, so please subscribe and share to them so that they can also have a sight of whatever is happening on my YouTube channel. Thank you once again for your attention, and until then, have a nice day. Bye for now.